All right, geometry students, today's lesson focuses on medians and altitudes. We should be able to use properties of medians and altitudes in triangles to discover properties of centers in triangles. We've already learned about two types of centers. Those would be the circumcenter and incenter. And we also know how they are formed by angle bisectors and perpendicular bisectors. So today we're looking at centroids and how they're formed by medians, orthocenters and how they're formed by altitudes, and we are going to do some application practice after that. So make sure you have your guided notes ready and let's get started. So first let's talk about probably the most important part of this lesson, which is medians and centroids. So let's first talk about what a median even is. A median is a segment joining a vertex of a triangle to the midpoint of the opposite side. So here's what we're seeing. In this triangle here, the blue segment is a median, and we know this because it extends from the vertex to the opposite side of the triangle and cuts that opposite side into two congruent parts. That's a median. So when you draw or construct three medians coming from each vertex in the triangle, you're actually creating the center that's called the centroid. Fun fact, the centroid of the triangle is the center of gravity of the triangle. So if you construct this perfectly, if you create all of the medians of all three sides and form the centroid in the middle, if you stick a pencil on that centroid, you will balance the triangle perfectly. So centroid is center of gravity. So just a quick definition, the three medians of a triangle intersect at a point called the centroid. The medians in this triangle, if we list them out, would be AE, there's one. We also have BF, and we have CD. So there are our medians. The centroid, of course, is point P. So included with medians, we have some special properties. So not only do medians bisect each side of the triangle, as you can see here, like so, the medians themselves have different lengths and different properties associated. So in medians, we're looking at, let's just use example AP, a portion of a median. AP is actually equal to double PE. So PE times 2 is going to equal AP. Larger portion of the median is equal to double the shorter portion of the median. Conversely, we know that PE is equal to half of AP. So basically, these are the same equations, just reversed. Next, just comparing the longest and shortest side median portions to the entire median, AP, the larger portion, is equal to 2/3 of the whole portion. So AP is equal to 2/3 AE. On the flip side, we know that PE, the smaller portion, is actually 1/3 of the whole. PE is 1/3 of AE. So we're going to use these ratios, these equations, to help us solve some problems here with centroids and medians. So first, we know that if P is the centroid of triangle JKL, in problem number 1 here, we know that JK, the entire side length here, is 22. KN is 13. And we know that OL is 18. We're going to find each measure. So let's start with Km. To find Km, we need to know that, of course, with medians, each side of this triangle has been cut into two congruent parts. which means that if all of JK is 22, KM is going to be half of that. So half of 22 would be 11. Next, NL. NL I know is going to be congruent to KN. If KN is 13, that means NL is 13. KL. KL, to find that, we need to know that KL is basically double KN. So 13 plus 13, that's going to give us 26. JO. JO is congruent to LO. LO is 18, that means JO is also 18. And JL, we're talking about the entire side of the triangle here. If we know that JO and LO are all 18, we just add that together. 18 plus 18, 36. So that's how we can use medians and properties of medians to find side lengths in triangles. For practice with that, try out problems 2 through 4. Now let's get into the properties of the medians and the portions of the medians themselves. So on number 5, if J is the centroid of triangle DEF, and we know that DH is 51, the entire length of DH is 51. GF is 60, so the entire median there is 60, and EI is 57. We're going to find each measure here. So we know the entire length of each median in this triangle. First, let's find DJ. So to find DJ, that is the longer portion of median DH. If DH is 51, that means that DJ is going to equal 2/3 of DH. It is 2/3 of the entire portion. So 2/3 of 51 would be, that would be 17 times 2, which is going to be 34. So DJ equals 34. For JH, JH is the shorter portion of DH, which means that basically 51 minus 34, or 1/3 of 51, is going to equal JH. So JH is equal to 1/3 of DH. And so 1/3 of DH would be 17. For GJ, I'll label that here. That's the shorter portion of GF, and GF is 60. So we know that GJ is equal to 1/3 of GF, and 1/3 of 60, that's going to be 20. To find JF, that's the longer portion of GF, and we know that JF is going to equal 2/3 of GF. So 2/3 of 60, that's going to be 40. And we're getting the idea here. For the next median, we know we need to find EJ. So EJ is the longest portion of EI, and we know EI is 57. So if EI is 57, and we need to find EJ, we know EJ is 2/3 the length of EI. And so 2/3 times 57 is going to be 38. And last but not least, JI. To find JI, the shorter portion of EI, that is 1/3 the length of the whole. So 1/3 of 57. 1/3 of 57 is going to be 19. For additional practice with finding lengths of medians and properties of centroids in triangles, try out problems 6 through 9. Let's take a quick look at the altitudes of triangles and how it forms the orthocenter. So if you were not aware, an altitude is a segment joining a vertex to the opposite side of a triangle so that it is perpendicular to that side. We often see altitudes when we are finding the height of a triangle. The altitude is just the tallest point of a triangle, forming a right angle with the base. So in an acute triangle like this, I would draw the altitude here. That's the tallest point. And sometimes altitudes can lie within or outside of a triangle. So that was in an acute triangle. In an obtuse triangle, it's actually outside. Pretty neat. So it's going to be this portion here, as long as it forms a right angle with the base. And in a right triangle, the altitude is just a leg of that triangle because it's already a right angle. So the orthocenter of a triangle is formed by the three altitudes of a triangle. And so in this diagram here, you can see we have altitudes AE, because you could see AE is forming a right angle with base BC. It's at the tallest point. If you were to rotate it around, it would be a little bit clearer. So AE is one altitude. You also have BF. That one's a lot easier to see because the triangle is, it's showing upright. BF is an altitude. And the last would be CD. They all meet together in the orthocenter P. So that is how altitudes and orthocenters work. So that was our lesson. Thank you so much for watching. Make sure that you try out the additional practice problems, especially with medians and centroids. Check your answers with my filled in notes and ask for support if you need it. Thank you again for watching. Have a great day.